Good morning, everyone, and thank you for tuning in. Hopefully, this will be a bit different because it's going to be a little bit technical, but also just a little bit of background about what we're doing and why. And hopefully that will stimulate some discussion and questions about how the center can help you, and you can help us by directing our research to be a little more focused. There we go. Okay, so by way of background, I'm originally a forester by training, but I realized real quickly there weren't jobs in forestry when I was an undergraduate, and I shifted over towards biology. And I got interested in timber as a material because I took a timber course and it was pretty cool. And I thought, boy, I could do that. So I gradually drifted into the timber side of this. But by training, I'm a pathologist, so I study deterioration from a perspective of the organisms that degrade it. And I spent about 35 years in Oregon at Oregon State University, directing the preservation program there, and then moved here a little under 4 years ago to take on this role of creating this center. And so it's based out of the University of the Sunshine Coast, which is just north of Brisbane. And why create a center is a good question. Why does Australia need this? Do we need another center? Lots of centers around in different areas. But if you looked at the loss of materials around the world, it was estimated that 10% of what we cut each year is replacing something that's been taken out of service. And I put timber here, but I could say the same thing about concrete and steel and other materials. We replace a lot of stuff, and we probably shouldn't have to replace as much. And so part of my gig is to really help make sure that we reduce some of that loss each year, both from the perspective of economic gains, but also from the perspective of environmental gains. If we do a good job, we have more forests for other things. The other reason is that when I was a youngster, many, many years ago, Australia was one of the leading research groups in timber durability. Australia and New Zealand were the top of the world. And that declined a lot as people retired and they weren't replaced. So part of the purpose of the center is to kind of reinvigorate that research capacity in the country. And I think it's particularly apropos now where we're looking at timber as it's not a new material, but people are rediscovering its value. And we want to make sure people use it properly. And so that's part of our goal here. Before I say timber, I'm going to talk about timber durability, but it's important to understand that everything on this planet degrades. And so when I talk about timber decay or timber durability, realize that I could have the same discussion about steel and concrete in many of the same ways. Everything degrades, and it really is all about water, which we'll talk about a bit later. Our partners at the center, first off, Forest and Wood Products Australia is our funding body. They've decided this is a valuable exercise for the country, and they've invested heavily in our center. Our other two partners are the University of Queensland and the Queensland Department of Ag and Fisheries. So there are two primary partners. We have a number of other research partners we're working with. University of Tasmania in Launceston and then University of South Australia at Mount Gambier are two of the other groups we're working with. And we really are looking to reach across the country to work with lots of groups because we have capacity here in durability, but lots of other people have other skills that we can marry in and take advantage of. So we are looking to reach out to others. We have a lot of people we've brought in, and some of them are based at UQ, and some of them are based at USC, and some are based at DAF, and you can just get a picture here. I'll show you a picture of the group at the end. But we have right now about 20 people who are associated with the center. So we're growing, and we're trying to grow a little bit more. So our center has a number of objectives, but I'm only going to talk about a few of them here. One is that we need to develop there's lots of materials coming along, lots of new, exciting wood-based materials, composites, modified woods, all kinds of things that are coming into the country. And while they've been looked at elsewhere, they aren't necessarily fit for purpose for Australia. And one of the things we want to confirm is that these materials will perform as expected here. So we're trying to develop data on emerging wood-based materials. We're also working on service life prediction because we think that's going to be really helpful for people as they view wood or timber against other materials to see, okay, what are the claims, how long do they last, and what will work. We're looking at fire performance because obviously bushfire risk has become a major issue across the country and actually globally. And so we're trying to understand that. We are also looking at the circular economy and reuse recycling strategies for timber. That's going to be increasingly important, not only for timber, but for everything. But underlying all that is to educate the next generation of durability researchers so that we don't have this loss of capacity in the country. So that's one of our underlying assets that we're trying to do, is develop people who understand timber and understand durability. So we're doing a number of smaller projects that all fit in under this. One is termites obviously are a major issue across most of the country, with the exception of Tasmania, and they cause major structural damage, and they create a lot of design issues. And so one of the things that was done about 30 years ago was to create a termite risk map across the country, and you'll see that to the right on the slide. That map is probably a little outdated. We're seeing changes in distribution of termites. Many are moving further south as a result of climate change, and we expect to see changes in how we need to build a little bit for some of the termite species. So we're working with a group in Victoria that has an app which the pesties can use to report termite distribution, and we're working with them to try and reassemble a better map for distribution that's probably a little more refined than what you see on this fairly broad scale. And that's, when we get that out, that's probably going to require some rethinking on building practices across the country, but particularly further south, say in Victoria. At the same time, we're also doing that, okay, what new materials are coming? What do we need to know about them? Will they perform as expected? And so there are a lot of materials coming in from offshore, things like acetylated wood, thermally modified timbers, newer composite materials. And there are lots of claims about how they perform. Many of them come from Europe, where there are not termite hazards and where they do not have tropical and subtropical exposures. And so we need to make sure that they are really going to perform under the surface, under the expectations here. So we need performance data for Australia. And we have been working on an exceedingly large scale test. There's about 8,000 pieces of timber in it, to look at some of these newer materials and newer chemistries where there are not public data, and to try and develop the data to show whether they will perform as expected or not. This is in cooperation with our DAF partners, the Queensland folks. This is just examples of some of the tests we have going. We have sites in Maroochy, north of Brisbane, and then way up far north Queensland in Innisfail, where the conditions are quite extreme. And the goal here really is to develop the data that shows whether these things perform, so that when somebody walks into an architect or an engineer's office and says, I have the greatest thing since sliced bread, they have data to really decide whether that's true or not. So that's a big part of the test here. At the same time, this test is going to inform a lot of the predictions that people are making about performance of treated timber. So it's got a kind of a dual purpose, and there's some other basic research we're doing around it, like what organisms are attacking the wood, where do they attack differently in different places. So there's a lot of other more basic scientific work that's involving a number of postgraduate students. One of the troubles with doing tests like this is the center is operating on a 5-year cycle. Decay doesn't really operate on a cycle. It operates on its own time frame. So this is a relatively slow process. So it's going to take time. But why is it important? Well, it's going to help people decide what materials are appropriate, and hopefully in the end reduce wood losses, so that we wind up with materials that perform as expected or better, and help people to use the resource more effectively. And we want to do that with all materials, but particularly with timber. That data, those data will feed into the service life prediction models. And let me give you some background about why that's important. Lots of engineering materials claim service life values, 50, 60, 1,000 years, doesn't matter what you say. But there were a series of models developed by the CSIRO in the late 1990s, early 2000s, to predict the performance of timber in different applications. And they were quite world leading. In fact, Dr. Bob Lester from CSIRO won the Wallenberg Prize, which is sort of like the Nobel Prize of timber, and for the fact that it was so world leading. Well, it's been a long time since those models were developed, and admittedly, at the start of that, the models were thin, on data. And one of the things we're trying to use the field trials for is to help produce some of these data that will help improve the models. If we can do that, these models become a lot more useful in predicting where you should use timber most appropriately. And if we do it right, then people have a better feel for what to expect of the different materials that are out there. So it has a short-term implication for, okay, here's how these materials that are coming on the marketplace will perform. In the long term, it says, all right, if you use this, you can expect 25, 50, however many years for this given material. And that's one of our big goals, is to give people a little more certainty around timber. We're also trying to help educate users about water, and I use this stick frame house as an example because it's quite a stunning piece of material. So one of the beauties of timber in Australia is that we kiln dry our material for framing, and it's mostly down to about 12%, which is a really good moisture content to start at because it controls checking and movement of the timber. But when we construct, sometimes it rains. And to give you a feel for this house has about, I don't know how many square meters of space it has, but basically it had 31,000 kilograms of timber in it, or 14,000 kilograms of timber in it. And it got 150 millimeters of water over the entire construction period before the roof was put on. So the moisture content rose from about 12 to about 50 over that time period. And that's important to understand because we know that when timber gets wet, it tends to move around a lot more and swell, but it also becomes more susceptible to mold and decay fungi and potentially termites coming from the ground. And so understanding how to manage that water becomes really important. And in a structure like this, it's relatively easy because we can just close it in this structure, put lots of hot air through and dry the timber down relatively quickly. And we've seen a lot of that with the floods we've had up north here, where we got enormous amounts of water in a very short period of time, a lot of flooding. But realistically, all people had to do was pull the gypsum board off, get airflow in there, dry it out, and then they could come back in once it was down to 12% or so, and just re-wall that and make it usable again. It's one of the beauties of timber, but if you leave it wet for too long, it becomes a problem. This is on a stick-built house. One of the things we're keenly interested in is what's going to happen when you get wet on a structure like this. Mass timber has come along, so here we have cross-laminated timber that's used in the 25 King Street building, but there's also lots of other products, mass plywood, gang nailed, laminated timbers. There's all kinds of materials that are larger timbers that will also wet on site. And one of the things we're keenly interested in and are working with our DAF partners on is, how do you manage that? How much water gets in? What are the implications of that water? And this work is just ongoing. So we're hoping to come out with, in probably the next year or so, with sort of recommendations. A lot of companies are already dealing with this. They're going to just-in-time delivery on site, covering materials and putting water barriers on beams as they're being put in, because they recognize the risk of these materials getting wet. They don't dry as quickly. They wet just as quickly. They wet fast, but they don't dry as quickly. And that will become really important for making sure these products perform as expected. And so that's one of the bigger things we're looking at, is sort of moisture behavior in timber, because while it is not directly durability related, it will eventually lead to durability issues. And so we want to make sure that these buildings are built properly and that they become shining examples of how to design and build with timber, not examples of what you shouldn't do. And our DAF partners are heavily involved with that. And we see that some things are simple. This is a really simple solution to capping the top of a cross-laminated timber section, is just take the material that was wrapped in and put it on top, because the water will run down the top inside, because these are not edge-glued panels. So sometimes it's really simple things that work, and we need to do more of getting that information out so people understand it. We're also very interested in the circular economy. Timber is really, it's an amazing material, right? It's renewable. We can grow more trees. It will, when you're done with it, if you let it just decay, it will go back into the atmosphere and new other trees can capture it. So it's got a circularity to begin with. It has low energy for processing. It is all the things you might want of a natural material. Unfortunately, at the end of life, it has some issues because it's fairly bulky. It's Australia is a big spread out place, and so things have to move long distances, and that can make disposal difficult in some applications. Particularly where we're concentrating right now is on engineered wood products and preservative treated timbers, because they right now pose some long-term concerns for how to deal with the materials. On the other hand, there are some really good options for how to get rid of that material, or not get rid of it, but repurpose it. And so we're working with a number of users of treated timber and engineered wood products, as well as some of the producers, to identify what volumes are out there, where they are, how you could effectively move them. Because if you've got a timber that's 1,000 kilometers from where it might be repurposed, it's probably not going to be very effective for reuse. And then try to identify the best options for moving and repurposing the materials so that we don't just use timber once, but we use it once, twice, maybe 3 times before we do something with it. At the end of the day, we can take that material and combust it for energy. But that would be the last thing we would probably want to do. We want to make sure we get the most out of our timber so that we sequester that carbon for as long as we can and make sure we maximize the value and grow multiple cycles of trees before we have to replace what we put in. But it is increasingly important in material selection, and we've been working with a number of partners to develop a program to look at the circular economy and look at recycling methods so that we can repurpose the materials that are going right now many times into a landfill, which we don't want to see. We also have an element of our partnership and fire performance. Now, fire in the Australian context is not often looked at as durability, but if we look at how bushfire risks are increasing because we've tended to encroach on the interface with the rural areas, we've tended to have more extreme cycles. So we're likely to see bushfire risk change over time. And there's a lot of work going on for how to understand that, how to manage it with designs and structures. But there's also a place for understanding how to use timber in bushfire prone areas. Timber is actually not a bad material in a fire. In a small diameter timber, it may have issues, but if you look at bigger timbers, I would much prefer to be in a large timber structure than I would to be in a steel structure. And the reason isn't because one is stronger than the other, because we designed them the same way. But it's really because when timber burns, it burns at a known rate based on the density and the intensity of the fire, and it will fail slowly. When steel burns or heats up, it will fail catastrophically because once it becomes ductile, it collapses. So timber is not a bad thing to have. We just have to understand how to use it. We have 7 species of timber in Australia that have BAL 29 ratings, which means they can be used in bushfire prone areas. One of the things we want to try and do is to develop data on other species. And our partners at the University of Queensland have excellent facilities for doing this. Dr. Felix Wiesner is our partner there. And we're trying to develop data on more species so that there's a broader range of materials that can be used in bushfire prone areas. We're also trying to understand some of the dynamics around combustion, particularly as it relates to preservative treated timber. We know that some treatments, particularly CCA, but also some of the other copper compounds, will tend to smolder after a bushfire passes through, and eventually they'll burn right through. We're trying to understand that process so that we can figure out what we might add to the preservatives to make them a little more resistant to that particular phenomena. And we have a PhD student who's working on that. If we could do that, that would help alleviate some of the losses when you get a very fast-moving fire going through. Because oftentimes, the fire will pass within 5 minutes, but a day later, the structure may fail, and that's because of this smoldering issue. We need to understand that better. We're also looking at fire retardants. They are not widely used in Australia, but they are used globally to a great extent. So there are many chemicals that can be used, that can be impregnated into timber to make it fire resistant, not fireproof, but fire resistant, so that it will slow the fire down. And mainly when we're looking at fire safety, we're looking at getting people out of the building. So we want to make sure that these things will perform. And there's a bit of work going on across the country to look at fire retardant chemistries to improve the performance of Australian timbers. And our UQ partners are part of that. And then the final thing we're working on in there is the methodologies for testing fire retardants are fairly prescribed. And in some cases, we've seen species where they don't catch fire, but they don't pass the test. And that seems a little absurd. And so one of the things we're working on is trying to understand what methodologies might be improved to get more realistic testing criteria so that some of these, particularly some of the really dense far north Australian species, Queensland and Northern Territory, that are going to perform well under these conditions, but are not BAL 29 listed right now. So there's a lot of work going on in that area. So those are all, that's all our UQ partners. I should say, we have a number of other projects undergoing right now. One is to look at the treatability of the Australian softwood resource. We have a lot of plantation softwood across the country. A large amount of that is preservative treated. And obviously a lot of all that softwood resource, with the exception of hoop pine, is non-native. And we're trying to understand how it differs across the country so that we can help the treaters understand the logistics of what they're producing, what their materials are. And eventually that might help us help people become more efficient in their material processing, but also help us understand some of the characteristic differences between the different regions and how that might affect the breeding programs for the different resources. And the other thing we're working on there is trying to understand the older material we have out there. There are probably 25 older tests that have been put in over time. A lot of them have been forgotten. And I'll give a good example of that. We recently looked at a test in New South Wales that was started in 1997. It had funding to put the test in, and it was looking at radiata pine decking because there was a fair amount of decking going into the marketplace. And the question was, when you look at a cross-section of a tree, you have the heartwood, which is the center of the tree that's not living, and you have the sapwood. Typically, when we look at treating standards, we treat the sapwood completely, and we treat a part of the heartwood. And our standards have some restrictions on how much heartwood there can be and how deep it has to be. But there were questions about whether, if you had any heartwood in a decking, would it perform? So this test was set up in 1997 by a fellow named David Gardner, who used to be with Department of Primary Industries in New South Wales. And it's a very, very nice test. Unfortunately, it was looked at for the first 4 years and then wasn't looked at again. And so, for example, we went out recently and looked at the test after 24 years. And we found many of the boards that were heartwood treated, or heartwood boards, were still in excellent condition after 24 years in a very severe environment where the test site had been abandoned and things were growing all over it. So going back and trying to mine some of those older tests is going to be an important part of what we do as well. We want to make sure that we don't reinvent the wheel, that we go back out and look at what's out there and make better use of the data we have. And part of the starting point for the center was to gain that consistency and longevity in being able to do research, because as we heard, durability is not a 3-year project. It takes years and years to develop data, and sometimes that can be frustrating. But on the other side of that, we want to make sure that we follow through. The other project we're working on is with our partners at University of Tasmania, is to try and look at some of the plantation hardwood resource, because much of that is now coming onto the market. It was originally planted for paper chips, but those markets have disappeared, and now people are trying to look at how to upscale that material. Well, some of those species are not durable, not naturally durable, and they need to be preservative treated. And so we're working with our UTAS partners to figure out, and our DAF partners to figure out how to make that more durable, and also how to evaluate it more quickly. We don't want to have a 30-year test for a product because nobody can afford to wait that long. So we're working with UTAS to try and come up with some accelerated test methods. The final thing we're working on, and I'll sort of cease there, is the next generation. The center was initiated in part because there was very little research going on. It was also initiated because most of the people who had worked in this field were aging out and needed to be replaced or enhanced. And so part of the center's mission is to educate postgraduate students. And we have now 11 postgraduate students engaged in different elements of our center partners at UQ and at USC. We also have, we're working with our partners at UTAS who have a number of students down there. The goal being to kind of get a cadre of people out there who understand timber, but also understand the role of durability in making sure that we have products that last, 50, 60, 100 years. And I think if we do that, we enhance the reputation of timber, but we also do good for the planet. So I think we kind of have a dual purpose here. I started to go off before, and I didn't at the start. I know we acknowledge the owners, traditional owners, and we didn't do it for Brisbane. And so where I sit in Brisbane, we acknowledge the Turrbal, the Jagera, and the Yagara people who were the traditional owners of the land. And we do pay our respects, past, present, and future to the people who are here. I think it's particularly important when we deal with a resource like timber to understand that people came before us and managed the land and used it. And our goal, because we're only temporary on this planet, our goal here is really to leave it a better place and to make sure that what we do doesn't harm the planet. And I think of using timber, I think is highly effective in terms of material use, as long as we use it properly. And a lot of what we want to do at the center and are doing at the center is to make sure that happens. We recently underwent a 3-year review on our program, and Forest and Wood Products' recommendation was to extend the center out for an additional 5 years. So we're just getting started, but we have a long-term goal here of basically creating that capacity in the country, making sure that we get information out to people, and basically making timber perform better than it does now. And I think it performs pretty well in most cases. With that, I would stop there, but also part of this discussion this morning is to get feedback on what we're doing. And I've only given you a few bits of what we're doing, but also to get a feel for what are your problems? What do you want to see us work on? And I know that's an open-ended question, but we want to make sure that what we do has purpose and application, and we want people to use timber more effectively. And with that, I would stop and ask if there are any questions.
Thanks, Jeff. That was a great presentation. I found that really informative. It's really fascinating when you talk about timber, because you very quickly get into this discussions about land management and custodianship and all these big political, local, national problems that we need to solve to really make timber the best thing that it can be. We have a few questions here already. I'll just kick it off with one of my own. Could you outline to me quickly the difference between white, brown, and dry rot?
Sure. So, white rot and brown rot, well, they're all in the same group of fungi. Not that that's critical, but white rots tend to be more common on hardwoods. So a lot of our less durable timbers will get white rot. It leaves the wood a bleached white appearance, and in the end, it'll take out almost all of the material in the wood, about 97%. Brown rots are a little different because they only take out the 2 of the components in the cell walls, and they modify the third, and they tend to leave the wood broken, brown, cracked. In fact, when people first started looking at brown rot, they called it combusted wood because they didn't know fungi existed. The dry rot is a misnomer. There are true dry rot fungi. They're a particular group of fungi that can grow up from the ground and into a timber that's perfectly dry. They're very uncommon. Dry rot is typically wood that got wet. It looks dry when you look at it. And so it's usually a brown rot that you're looking at.
Right. So fundamentally, it's all about
more about brown rots on softwoods, we're more about white rots on hardwoods.
Right. Interesting how a misnomer can take off like that and get rooted in people's consciousness, in the consciousness. I've got 3 questions here from the Q&A. So we'll start with the first one. This is from Jerry. You've stated a moisture content update, a moisture uptake from 12% to 50% due to prolonged saturation. Not sure if builders wait or check if the moisture has dropped to 12% prior to closing this in, as it could take several weeks. The question is, how would this retained moisture affect the long-term performance of the structure, and in particular gang nails?
Good question. First off, I think if you're trying to dry a structure out, most people will use surface moisture meters, and you have to be cautious about them because they're only telling you what's on the surface, not what the center of the timber's like. And particularly recently with the floods, that's a big question because you may get the surface dry very quickly and the interior may be still quite wet. So that's something to consider. If you have moisture trapped in the cavity, you're likely to get mold inside the building cavity. And that's the main purpose for drying it out. It will dry eventually. It'll just take a while to do that. And you may build up some mold. If you're in southern parts of the region where there's insulation in the walls, that can be a problem. So getting the moisture content down is important, particularly when you get very wet conditions like we've had, 20 days of rain almost recently here. I feel like we're going to build an ark and move on.
We do seem to live in a water world these days in Australia. I think everyone's really...
Yeah. So, but I think, a moisture meter is a really useful tool for figuring out what to do with timber. And we typically use a 20% moisture content as sort of a cardinal value. And that's because we know that once you go above 30, decay fungi will start to grow in the timber. And so 20 is kind of a safety place to be. If you go into far north Queensland, you'll get up into that range just for the relative humidity. So you have to be cautious about how you do it. And so how we deal with moisture is a little different in each part of the country because of our climatic conditions, our extremes.
I suppose that would present extra challenges to a national approach to the problem because you are talking about so many different latitudes.
And you just have to be careful. We also have to bring in air conditioning. We've got cold surfaces and hot climates, hot and humid climates. There's a lot of stuff to building science that we're starting to learn a lot of that. I don't understand it. But there's a lot more work to be done, particularly as it fits into tropical and subtropical climates, because most of that work is done in Europe and North America, where that's not an issue.
I've been doing a lot of research into the passive house style designs over the last couple of years, and one of the common rebukes to it is that, we're in Australia, we like to live outside. And I think that this last 2 years has shown that, it's really brought a focus onto the quality of your internal environment for everyone, I think.
I think you can build it. There are passive houses being built in Australia. You just have to be aware of some of the climatic differences. So there's nothing wrong with the house.
Yeah. But it's just like one of the main criteria or one of the main performance outcomes of good passive house design is that your interior environment's a high quality environment from particulate matter, but also living things and mold. And that as a safety measure, I think has been tested a lot in the last 6 months.
For sure up here and down your way. But mold is, so one of the things about mold, people get very worried about it. And I'm not going to negate that molds can cause issues for some people, because they do. And it's an allergen. It's really going to aggravate things like asthma. Realistically though, mold is an indicator of water. And if you look at it as that, it's an indicator that you have a moisture problem in a building. Either you're not ventilating enough, you've got cold surfaces that condense. And so really when you see mold growing on something, you got to step back and say, okay, why is it there? Because if you can look back at why, then you can start to look at the prevention. But if you just go and clean it off, that isn't really solving the problem.
Band-Aids.
Yeah.
I've got a question here about the disposal of LOSP timbers. So this is from Peter. Safe disposal of LOSP timbers currently goes to landfill in Victoria. OSB producers don't want it, and it's not suitable for burning. And I just asked for your thoughts on that.
So this is our circular economy move. And the states differ in how they deal with this, but right now landfill is probably the most appropriate end use for it, because there's not a market for things like making OSB or even taking it and making particle board out of it. But there's an effort going on to make that change. So it's kind of a watch this space. There's work in progress sort of thing. But we see that as an important issue, not just for LOSP treated, but all treatments.
Yeah. One of the main benefits of buying something fresh from a factory is that you have certainty around its properties, whether they are structural, geometric, whatnot. And so how would you feel about the statement that the circular economy is a problem of assessment, in terms of, like, if you're going to think of a building site as something to be mined and reclaimed, the effort that it's going to take is, well, if you know that the ores in the, or a large part of mining is determining what ores in the ground, if you know what timbers are where in a building, with something that's well documented, like a modern mass timber building, that's probably quite easy because there are good as-built drawings. But with something like a stick-built house, how do you see any inroads to addressing that assessment problem?
We actually, the work we're trying to do with the circular economy, we cleverly avoided that. Not because it's not an issue, but we've tried to look at some of the lower hanging fruit, and that would be things like a truss and frame manufacturer, where they're doing lots of cutoffs, and some of that material is treated, and how do you repurpose that? Things like vineyard posts, because we replace about 1 million vineyard posts a year in Australia. It's a big business. And how do you repurpose that material so that it doesn't go to the landfill? Same thing with utility poles. So those are the easy ones. The framing in a building is a little more difficult because it's got connectors, it's shaped, cut, different sizes. It becomes a little more difficult. But there is a good market for repurposing some of the bigger timbers. And there's a number of companies on the East Coast down into Victoria up here that resaw utility poles, bridge timbers into other products, and they're doing hardwoods because they're exceedingly valuable materials. So I think we're going to find that, if you look at a landfill cost right now, it's probably about $150 a ton for flat out disposal. It's about $250 a ton for treated timber disposal. That's not going to go down. And so we need to find ways to, first off, keep that out of the landfill and reuse it for something. So I think the economics are going to drive some of those repurposing pathways. And probably the biggest problem we'll have with that is going to be distance. How do you move it somewhere to use it?
The tyranny of distance in Australia is certainly something that
tyranny of distance we have.
We suffer from a lot with all of our operations, which in my opinion is a major inroad for the European suppliers. Got to a question here. This is from Heath Bustle. Hi Jeff, fantastic presentation. Could I ask if any work is being done in relation to variances in preservative treatment quality / effectiveness? That seems to be somewhat based on where the treatment is done, i.e. different treatment plants / operations. So variances in treatment quality and effectiveness based on
that is something. There is a national standard, obviously. Australian standard, or Australian New Zealand standard 1604 specifies the treatments of timber, and the standard itself is fine. It is fit for purpose, and it just was renewed a year and a half ago. There's no national quality scheme here, and so treaters are on their own for how there is a national, well, I shouldn't say that. 1604 specifies quality control schemes, but there's no broad oversight by an agency or somebody that's looking at treated timber. I come from a place where that does happen, and from a different perspective. So there can be variations in treatment quality, and I think I'm gonna stumble on this badly. There is a need for some sort of uniform system for quality control. And it comes about because there are probably about 200 treaters across the country. There are some very large ones. They probably occupy 70% of the market, and they're the primary producers you see. And by and large, they've got the resources to do quality control on a regular basis. Some of the smaller treaters will struggle with it. And they're doing a lot of contract treating where they have no control over the resource coming in. There's a need for that, and we are working on that a little bit. I didn't talk about it, but.
So you mentioned the national strategy. So in North America, there is a coherent national set of guidelines around that.
There are, well, the national standards in the U.S. are consensus standards, and so it's a private body that does them. But those standards are into the building codes as they would be here. But they're also they are, if you use the American Wood Protection Association standards in North America or the US, by putting that stamp on your timber, which you have to do, you automatically open yourself up to potential inspection by a group called the American Lumber Standards Committee, which is federally promulgated through the Department of Commerce. So they can walk in anywhere in the supply chain and look at timber. And so there's a little bit of oversight on that. And then the companies, there are also some private assessment programs too. So there is a system there that's probably, it's not perfect, and it has its own sets of warts, but it's a little more structured than it is here.
Right. So we don't have that sort of active
No.
oversight in the Australian supply chain.
Part of that is, there's 350 million people in the United States. It's got everything scale works differently, and you have to be aware of how the market works. By and large, most timber is treated properly. And there's going to be some that will not be treated properly just by virtue of the variability of the material. But if it's treated near to the retention, it's probably going to perform, which is not a good way to describe it. Well, when we promulgate standards, when we treat a piece of timber, we say that like all the sapwood has to be treated and all this, and we have a certain amount of chemical we put in or retention. Those retentions are far higher than the minimum, right? There's always a safety factor in them. So if you're treating, even if you're 60% of that minimum, it's probably going to perform. It's when it goes below that you start having troubles. So and that's just how the standards have been developed, because we understand that timber is such a variable resource that we have to adapt that.
Assessment again. Information control is important. Got a question here from an anonymous attendee who asks, how significant are different fixing strategies for lifetime and reuse, recycle, etc.? And I suppose I'd expand on that and ask, is there a preferred fixing strategy, let's say for a house, or as opposed, like if we're going to compare, say, standard framing versus advanced framing or those kinds of fixing strategies, is there one that you really prefer or one that you really dislike?
No, you mean for potential reuse? I don't know that there's one that we've come. I said my guess would be that most of the things that would make it easier to reuse are going to be uneconomical because they're logistically difficult, or the cost of the metal for the fixings is going to be too much. I think we're gonna sort of live and adapt with that as we go. And if you think about it now, what we're building now, if we do it properly, is not likely to be replaced for 50 to 100 years, if assuming that we stay with the same styles and designs. So I don't know that what we're going to deal with over the next 50 years is going to be the stuff that's already in place, and that's going to be nailed. Maybe gang nails because you've got trusses, and those are relatively easy to deal with particularly in a shredding environment where you're just going to make it into a composite or you're going to burn it. Those are relatively easy to recover.
Right. So nail plated type solutions are positive.
I think so. Yeah. And they make more sense for a lot of the trusses. And, we're seeing a lot of movement towards prefabrication off-site and then bringing in fully fabricated panels. And I think that makes all kinds of sense for so many reasons, logistics, waste on site, tightness to tolerances in materials that we can do. There's so many more things we can do now because we have the production, we have the demand within some of the bigger cities that make that economically feasible.
We can get better manufacturing precision.
Yeah.
So things like dowels and bolts would be poor.
Yeah, there's a lot of work. And some of the things that are going on are not just here, but in Europe are just, there's an amazing amount of work going on in prefabrication.
How would you go about, so you touched on moisture meters before, and I'm aware that they're not a panacea and they can lead you down the wrong path if you take their service measurements too seriously, if you're trying to assess a whole, let's say, a mass timber block. How would you go about assessing a piece of mass timber for moisture content if you had to?
It's a really difficult one to do because if you just use surface moisture, you may miss something. There's not a good way to go at that yet because it's too big. I mean, a pin moisture meter would get you 75 millimeters into the timber. That's about the best you can get. And it's also hard because you've got moisture intrusion is likely to be along the edges of the pieces because it's not glued on the edges. You'd have to look at top and bottom. You'd go to likely places like if you got a floor wall connection, I'd go to the bottom of that because if there's been wetting, that's where it's going to be wet. You'd have to look kind of intelligently at where the moisture is likely to accumulate, and it's always going to be down. Gravity is a great thing, keeps us on the planet, but water is going to move down in a building. So you go kind of the lower point and start working your way up.
Yeah, so prevention really is the best medicine.
One of the things about meters, which a lot of people don't understand, is even though the meter shows values above 30%, most meters are really only accurate between about 16 and 24.
Right.
And that's okay because it shouldn't be higher than that, right? So if you go in and it's over 24, well, it could be 40. You don't care. You have a problem. You have a moisture
You've got a problem. Yeah.
So they're indicators. They're not exact.
Yeah, I think people there's a tendency to rely on that probably a little bit too much.
I think the other part of that is, and we're doing some of this with our DAF partners, is I think when we get to some of these bigger mass timber buildings, we have to set up some moisture. We have to make the building smart. We have to set up some sites in the building that are censored so we can detect moisture changes. And there's a lot of work going on that around the world right now, not as much in Australia, but it's starting. For example, our university, Sunshine Coast, is building 2 mass timber buildings on their campus in Petrie. And one of those is going to be censored to track moisture over time in different spaces in the building. And that's going to be good, not only because it's good to know that, but it's also going to be helpful because it's a teaching tool for the engineering students who are taking classes there. So they're going to be able to go in, hit a screen, and they're going to be able to see what the moisture is across the whole building and humidity and everything else. And so it's a learning tool as well.
That's amazing. That kind of rich data is going to be very useful.
There's a lot of that going around the country and across the world because everybody's starting to realize we have the tools to do that. Sort of the self-reporting building is going to tell you if it's got a problem.
Yeah, that's cool. That's something I'd love to see. All right. I think we've gotten through all the major questions, so I might do the wrap up. So I'll share the screen. So yes, the accessing the formal CPD. So we have had the 3 CPD questions is a self-assessment only. The cert of attendance will be sent out to all the attendees. And it's up to you to bring it to your industry to get those CPD points ratified. So the 3 questions were: what proportion of timber cut per year fails in service? It was about 10%. How does decay influence fire performance? Probably a bit of a misnomer there. Probably should have been.
I didn't touch on that one. I'd say it really doesn't. So let's go past it.
Trick question. Gotcha.
Yeah.
And the last one was: what design approach creates a focus on building element longevity? And that is the LCA approach, or the life cycle analysis approach. So yeah, our next webinar in a fortnight is going to be the last of a trio of seminars on AS 1684 on timber tie downs and connections by Tim Rossiter. So make sure that you are in the loop for that one. And yeah, just a last reminder to please sign up if you have any cool projects that you think would be good competition for the Timber Design Awards 2022. And as a reminder as well, we're undertaking, we're seeking interest for people who would like to help us do a mass timber full scale test program. So a full burn. So that's going to be an exciting project. So if you're interested in talking about that, please feel free to reach out. And yeah, thank you so much, Jeff, for that. That was a great presentation. I certainly learned a lot, and there was a lot of interest going on in the chat and the Q&A. So I think everyone else found that quite interesting too. So with that out of the way, we're a few minutes early. So I think we'll call it there. Thank you so much, and we'll see you in the next webinar.